Okay, example 7 says, is this continuous at x equals 1? So what you try to do is figure out, if I stick 1 in there, do I get the same thing? Because neither one of this is continuous, and then it says, but it's less than 4, less than or equal to 1. So we have a break, basically. It's doing this, and then it's equal to 4. X is greater than 1. And so we just want to make sure that this top one equals 4 at 1. So if I put 1 in there, I get 1 squared plus 2, which is equal to 3. And then everything after that would be equal to 4. So this is going to have jump discontinuity. Okay. In other words, when I substitute 1 in, I got 3 for the top. And when I substituted 1 in, which there's no substitution, I get 4. And those don't match. So like if you were graphing this, this is x squared plus 2, right? Boom, boom, right? That's a quadratic. And so we're at 1. This is at 3. So the graph is 1, 3. And so it cuts right there, right? And it goes, hey, I'm right here. And it's filled in because it's less than or equal to 1. So it's filled in dot. And then starts at 4 and goes like that after. So you can see it has jump discontinuity. Going to 8, we have another piecewise, and it wants to know, is it continuous at 2? So let's look what's happening at 2. If you put in 2 squared, you get 4, and what do I get at 2? I get 1. So again, this is definitely not okay, hang on, let's see, wait. Part of me is like, did this happen? It's removable. Yeah, so it's not continuous. It's again, is it removable? Yeah. You can, this is another example where if I had just said this was 4 instead of 1, okay, it would have been continuous. But because it's 1, it is removable. So again, that just looks like this, right? And at 2, f of x should be 4. And so it has this hole right there because it says everywhere except there. And then it says, what is it there? At 2? Well, it's at 1. So there's a dot down here. And so that's your removable. All right, and one more example. Show that, okay, x squared minus 5 over x plus 1 has a root between 2 and 3. Okay, ding, 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 bells should be going off, okay? This is Rolle's theorem. It's asking for proving about a root between two numbers. So anytime, which is what? The intermediate value theorem, right? Okay, value theorem. So cheat sheet out for that, right? But I can do it, I hope, pretty good without the cheat sheet. Explain what we mean. First of all, you got to have continuity. So you're going to say that only cares about continuity, by the way, between 2 and 3. And so you're going to say, you're going to say, to prove this, that you have to prove it's continuous. So, but you also need to show for this, I'm on the wrong one, that you have, that one of them's negative and one of them's positive. So just at the very beginning, you start and you go, okay, f of 2 is equal to, and you pray one is positive and one is negative. If you don't get one positive and one negative, you can't show using intermediate value theorem. So I don't know why they would ask you that if it didn't work. So f of 2 is 4 minus 5 over 3, which is negative 1/3. So we got a negative number. F of 3 is equal to 9 minus 5 over 4, which is equal to positive 1, right? 4 over 4. So we have one positive and one negative. So here's how you show it. You would say, because f of x is continuous between 2 and 3, and f of 2 and f of 3 have opposite signs, right? By the intermediate value theorem, there exists at least one C such that, f of C equals 0 for the 0, because that's what it wants, a root. Okay, so that's what you would say. First, you have to make sure it's continuous, and it is, except because it's only discontinuous at -1, and then f of 2 and f of 3 have opposite signs. So by the intermediate value theorem, there's at least one C on the interval. You could say on 2, 3, probably to be better here, such that f of C equals 0. All right, so that's today's lesson. You've got a review circuit on limits and continuity. So I've got the answer key for that. That stuff is copyrighted, which is why you have to have the zebra passcode, just in case you were wondering why.